Can start. Yeah, good afternoon, everybody. How are you all? Today, we are looking at another topic, though not new to some of us, but it will serve as a form of reminder or to consolidate our understanding of the topic matter. So I said we are looking at hydrocarbons, so that is the topic. So on it, we'll be looking at the meaning of hydrocarbon, meaning sources of hydrocarbon, and then classification, and if time permits us, so we might look into individual classes of hydrocarbons, as in different homologous series. So I can as well put homologous series here. Now, to start with, the first one, meaning of hydrocarbons. So hydrocarbons is an aspect of organic chemistry or organic compounds that consist of carbon and hydrogen only. Hydrocarbons, organic compounds that consist of hydrogen, from the name, hydrogen and carbon only. Hydrogen and carbon only. So this group of organic compounds can only contain hydrogen and carbon and nothing else, no any other element. For instance, we have something like DC2H5OH, so it is not a part of hydrocarbons. We have CH3COOH, it is not a part of hydrocarbons. But we have C3H8, we have C3H3, we have C4H8, etc. These are regarded as hydrocarbons, as introduction. Now, classes of hydrocarbons. So, we've seen the definition. So, classes, basically, we can classify hydrocarbons into two major groups, aliphatic and aromatic, as we've learned before. So, aromatic has to do with those that have benzene ring or benzene nucleus. That's their characteristic. Aromatic hydrocarbons. So those with benzene ring. Benzene ring, or what we call benzene nucleus. So every other aromatic hydrocarbons are derived from benzene. So how does benzene look like? Benzene itself has this chemical formula C6H6. So if you want to come up with structures or drawings of benzene, there are so many of it, but the common ones that we have, at least simple ones that we can have. So we have something like this. So this double bond, double and double. So alternate double and single covalent bond. You can use this one to stand for benzene, or we have another one like this. This one too can stand for benzene, to tell us that these alternate double and single covalent bonds are not really existing in benzene. Instead, these two bonds, single covalent bond, double covalent that we have here, they are of equal strength. They are the same in terms of strength, in terms of chemical reactivity. So as a result of that, we can also represent that single structure as this. Just draw this hexagon and then put a circle in between. so that all these bonds are equal in terms of reactivity, in terms of strength, and the rest like that. No, so that is about aromatic hydrocarbon. Benzene and derivative. For instance, derivative for benzene, we have one we call toluene. Toluene has this structure. If this is a benzene structure, as we said, so toluene, we just add CH3 to one side. So by its IUPAC name, we call it methylbenzene. Methylbenzene. Okay, now, so the other part, aliphatic hydrocarbons, alkanes, cycloalkanes, alkanes, and alkynes. Aliphatic hydrocarbons. So those are the various classes or homologous series that we have under aliphatic. So these are branch chain or linear chain carbon atoms only in terms of the arrangement. So they are branch chain or linear chain carbon atom like this, just move linearly, or move linearly like this, then we now have branch like this, hydrocarbons. So, but there's one part of them, cycloalkanes, that look closely to benzene. And that one looks like this. We have carbon atom like this, another one like this, another one like this, another one like this, another one like this. So like this one, these 5 carbon atoms are joined together in form of what we can call in a circular manner or cyclic manner. It can even be 4, it can be 3 like this, it can be 4 like this. So the characteristic property of this one is that all the carbon atoms are joined together in a circle or circular manner. But they are different from that of benzene in the sense that there is no double bond. There's no area where we can see double bond there. So to complete those structures, we add the appropriate number of hydrogen atoms to it. So each of the carbon atom here, we take two hydrogen atoms for every one of them. Similarly here, CH2, CH2. So these are cycloalkanes. These are cycloalkanes. So they look very closely to alkanes. Why alkanes are like this? All this one, if you want to represent it with alkanes alone, it can be linearly arranged, or we have some carbon atom to form or act as branches to the main chain. So in such a case, alkanes has a general molecular formula CnH2n. Alkanes, general molecular formula CnH2n plus 2. But cycloalkanes have general molecular formula CnH2n. So that is 1 or 2 hydrogen atoms fewer than alkanes. 2 hydrogen atoms fewer than alkanes. So N in each of these cases, N is greater than or equal to 1. So our N cannot be 0. Start from 1 minimum and then it goes on like that. So then alkanes as another group, they under aliphatic. So they are also hydrocarbons, carbon hydrogen only. And they can be represented by this general molecular formula. And the last one there, alkynes, CnH2n minus 2. I hope you are following it. Okay, the next slide we have here, that is another division of hydrocarbon, another way, looking at the level of saturation and unsaturation of our carbon atoms. So we have 2 basic divisions as well, aliphatic and aromatic. So under our aliphatic, we have saturated hydrocarbons and unsaturated. So as we have it there, these are regarded as unsaturated hydrocarbons. That is alkanes and alkynes. While alkanes are regarded as saturated. They are saturated in the sense that each of the carbon atoms are fully filled to their capacity with single covalent bonds alone. Each of the carbon atoms are fully to their capacity with single covalent bond. So, but unlike unsaturated, so they cannot entertain or accommodate any other thing except there is going to be replacement or displacement. So, but unsaturated hydrocarbon, we have a situation where we have at least in between two carbon atoms, there is a double or triple covalent bond like this, at least one, if not more than that. So we have something like this. So for this one too, I have something like this. So at least double or triple covalent bond. So that gives us unsaturated hydrocarbon in the case of alkenes and alkynes respectively. Okay, so we can see old names for them. Alkenes known as paraffin, as in old name, mean inert gases or inert hydrocarbon. Then alkene, olefin, and then acetylene for alkynes. Okay, this is the definition of hydrocarbons again. And then here we have a table giving us the general structure for this homologous series. And then the functional group, good, the functional group. So we can see the functional group for alkenes. So having only carbon to carbon single covalent bond throughout. So there's no specific functional group, or we can say there's no peculiar functional group for alkenes. But for alkenes and alkenes, the functional group there is the double bond. That is double covalent bond. And for alkynes, the functional group there is triple bond. That is triple covalent bond. So you might perhaps want to ask for the meaning of a functional group. What is a functional group? What is a functional group? So functional group can be defined as a bond, as we can see here, or an atom or group of atoms that determine the chemical properties of a given homologous series. Again, functional group can be defined as a bond, as we can see, or an atom or group of atoms that determine the chemical properties of a given homologous series. For instance, alkenes, as we said, there's no peculiar functional group, or we say there's no functional group. But for alkenes, the functional group is double bond, and that determines the chemical property of those group of organic compounds. Similarly, triple bonds for alkynes, so it determines the properties of those group of organic compounds. And then for other homologous series as well. So that is what we call functional group, as we can see. For aromatic, so we call it phenyl group. So that's their own functional group. The next slide here, we have some diagrams there, the familiar diagrams common to us in our environment to see the application or uses of hydrocarbons. Our cooking gas, propane most especially, so though sometimes on rare occasion we do have it as butane, but we know that, okay, these hydrocarbons can serve as domestic fuel for us. So as cooking gas, propane is one of it, butane is another one. And then ethane, so which belongs to alkenes as homologous series, is found in several fruits and hastening the ripening of those fruits. Then ethane, which is not acetylene as in the old name, so we have it in miner's lamp. So that is what they use. And all those our people that go into bush for hunting of animals, and then those that engage in wedding activities. So they make use of this type of hydrocarbon as a fuel. Okay, our next slide. So acyclic alkane and cycloalkanes. Okay, just a little note on it. We want to put it down in the next 60 seconds. The next 60 seconds. I'm counting down. Okay, now we are done. Now the next slide, alkanes. It's a contain carbon to carbon and carbon to hydrogen sigma bond. Sigma bond, that is single covalent bond that we have there. That's what we meant by that. General molecular formula, we've taken note of that. CnH2n plus 2, where n is greater than or equal to 1. Taking note of that. Then in naming system for alkanes, it ends with the suffix ana, just as we have for alkanes. Alkanes end with ene, while alkanes end with yna. Then their suffix in naming them. So alkane is ana. The Latin name, that is the one that acts as prefix, we can derive that one from the common names of our polygons. Common name of our polygons, at least starting from the 5-sided polygon we call pentane, 6-sided polygon hexane, 7-sided heptane, and the rest like that. But the first four, so that is the first alkane that consists of one carbon alkane. So the prefix for that is met. So we add it plus ane as in suffix for alkane. So the one with 2 carbon, the prefix is et. So plus ane, that's give us ethane. 3 carbon alkane, the prefix is prop. Add it to the suffix, so give us propane. And 4 carbon, the prefix is but. Add it with ane to give us butane. So starting from 5 carbon alkane, so we start apply the names of our polygons: pentagon, hexagon, heptagon, and the rest. So pent plus ane, that's pentane. 6 carbon, hexane, and like that, up to 10 carbon hydrocarbon. And according to our scheme of work and our WAEC and ECO syllabus, we are expected to know the names up to 10 carbon hydrocarbons. So also for other homologous series. So we have decane being the last one, I think carbon hydrocarbon. So we can see the names here. You can see the names and their structural formula in condensed form. Okay. And we are still together. Okay. Next slide. Straight chain alkanes, the one that take the name N in front, that is normal. N stands for normal. N stands for normal. Straight chain alkane as in N-pentane, normal pentane. Take any from meaning that normal and so that alkane is unbranched. So there's no branch here. Okay. And if we say N-butane, N-butane just means something like this. 1, 2, 3, 4. So with their corresponding hydrogen atoms. Now we can see it. So this is N-butane, meaning normal butane. So also we have N-pentane, that's normal pentane. That's 5 carbon. So always start with the carbon atom, then supply the hydrogen like this. Okay. Now, in a case when we have branch alkanes, it's a one methyl group. So there's something called methyl group. So methyl group is derived from the base name alkane itself, alkane. So the general name for that methyl group belongs to this particular homologous base, alkane. So it is one hydrogen fewer than that of alkane. So we have the general molecular formula CnH2n plus 1. CnH2n plus 1. So we follow the same naming system as in the first member of alkane is methane. So the first member of alkyl group will be methyl. So we only change the surface. The prefix is the same, met, 1 carbon. So methyl. So the second member, which is ethane under alkane. So for alkyl group, the second member is ethyl. Methyl, ethyl. So ethyl with this formula C1H2, 2 times 1, 1 plus 1, that's 3. So 2 times 1, that's 2 plus 1, 3. So CH3, that's for methyl. And then ethyl, C2, 2 times 2, 4 plus 1, that's 5. So C2H5. But we should take note of this particular group. They cannot stand alone. They stand as a compound or an entity. They always join to a particular uh, compound or another entity. As in why? Because the carbon atom is not fully occupied. It's not fully satisfied with the corresponding hydrogen or bonds that we're supposed to have around it. Check it. So that's why we should always write it like this. So you can't just write it like this. No, this is wrong. Or C2H5, it is wrong. But unlike alkanes, CH4, yes, this is correct. So this is also correct for alkyl group. C2H6, this is correct. This is also correct for alkyl group, but not like this. So you should always put something like this there for it to be corrected. Is that taken? So we should take note of that. So we say if one methyl group is on the second carbon, then we call it iso. Iso, that's the prefix we add to the name. So simply means isomer of the name we have against it. So we say isobutane, for instance, you have isobutane. Isobutane means isomer of butane. This is normal butane, as we can see here. This is normal butane. Isomer of butane means that it will contain the same number of carbon and hydrogen atoms. There's no difference. The same number, carbon 4, hydrogen 10. So isobutane 2 will be C4H10, no difference. The only area where we are going to have difference is the spatial arrangement, the structural drawing or formula. For instance, we can have our carbon like this, just 3 carbon like this, and the last one here. So I'm still going to supply the exact number of hydrogen atoms like this. I hope you are following it. So this one, I can put it like this, CH3. We count it. Carbon 4, 1, 2, 3, 4. Then hydrogen 10, 1, 2, this is 3, 5, 6, 7, 8, 9, 10. So C for H10. So this is N-butane, and this is isobutane, that is isomer of butane. So it is still acceptable as isobutane, but that is not its real name. That is not its IUPAC name. When we get to naming system, we are going to see its IUPAC name. So we can have for other members of alkane to isopentane. So it will contain the molecular formula for pentane, that is C5H12. That is the same number of carbon and hydrogen atoms, but the arrangement in space may differ. For instance, isopentane, so still have C5H12. I may have 4 carbon atoms linearly arranged, and just one as branch. Okay. Are we following? Okay. So we can count it together. 1, 2, 3, 4, 5. 5 carbon. Hydrogen. 1, 2, 3, plus 3. 6, 7, 8, 9, 10, 11, 12. So C5H12. So as I said earlier on, this one too, we can simply refer to it as isopentane, but it is not the IUPAC name for it. So when we get to naming of alkanes or hydrocarbons, we are going to look at its IUPAC name. Okay, the next one. Okay, they talk about alkyl group here. I've explained that. One hydrogen atom is removed from alkane, we have alkyl group being formed. General molecular formula CnH2n plus 1. The suffix ANA in alkane is replaced with YNA. An alkyl group in organic structures, we usually represent it with R, capital letter R. Anywhere we see capital letter R, it stands for alkyl group. Okay. Okay, this one is showing how alkyl is being formed from alkane as homologous series. Okay. Naming of alkanes, or what we can simply call nomenclature of alkanes. So for the branch complex alkanes, IUPAC system is used, as we have in the case of isobutane, isopentane, and some other more complex ones. So in the IUPAC system, the following rules can be used. So we have certain set of rules that we should follow always. Okay, so naming or nomenclature of alkanes. Naming or nomenclature of alkanes. So the first rule states that we should always determine the longest continuous carbon chain. Determine the longest continuous carbon chain. So this will give us the parent name or the base name for the alkane. Longest continuous carbon chain. That is our carbon atoms. We should try as much as possible to locate the longest one from there. So, and with this, we assign parent name or base name to our hydrocarbon. So, as we can see on the screen, so we check this one. This is a branch alkane. In fact, we can see two branches. We are trying to now check the longest one. 1, 2, 3, 4, 5, 6. Can we all count it together again? 1, 2, 3, 4, 5, 6. Is that taken? So these other carbon atoms that we've not counted, these methyl groups, so are regarded as branched groups or substituent groups. So if we try to count in any other way, we won't get up to 6. We cannot get more than 6, except lower. 1, 2, 3, 4, like this. So 1, 2, 3, 4, 5, 6. This one is still 6, so we still come back to the same name. 1, 2, 3. 3. 1, 2, 3, 4, 5, 5. So 6 is the longest continuous carbon chain here. So that will give us 6 carbon alkane, 6 carbon, pentane 5, 6 carbon hexane. So hexane is the base name. So that is what we meant by base name or the parent name. The second rule said the number, we should number the carbon atom in the longest chain. So starting at the end nearer to the branch, starting at the end nearer to the branch. So let me try to come up with that. Okay, we can see it on the screen. That will save our time. So 1, 2, 3, 4, 5, 6. So we should assign number to arrive at that name, hexane, and 6 carbon. 6 carbon, hexane, good. That's the base name. Then, so in order to number this, the rule says that we should start at the end, nearer to the branch. In other words, we should assign the lowest number possible to the branch group. We should assign the lowest number possible to the branch group. So, as it is now, we should start from this other end, 1, 2, 3. So, the first branch here, we attract 3. But if we start from here, 1, 2. So, the first branch here, we attract 2. So, we go for that. So, 1, 2, 3, 4, 5, 6. So, we go for that one. So, we have it like this. 1, 2, 3, 4, 5, 6. Okay, here we have CH3, and on 4 we also have CH3. So the remaining hydrogen atoms. So according to rule number 2, the numbering should be from this side: 1, 2, 3, 4, 5, 6. Is that taken? So the side nearer to the first branching. So we go for this rather than starting from a 1, 2, 3. So before we get to the bound, we will be on the third carbon. So we go for this one. So we have hexane, the base name. Those carbon atoms that we've not counted or that they are not part of this name, hexane. For instance, this one and this one, you can circle them like this. And of course, we can see CH3, CH3, okay, from our previous explanation, we say they are called methane. So we call this one methylhexane. But that is not all. Let's continue with the rule and see other things to be added. Rule number 3 says that so the position of groups bonded to parent chain. So as in we've numbered it, that's the position. And then it goes on. If there are more than one identical group, as we have in this case, 2 methyl groups, so we should use the appropriate prefix, as in di, tri, or tetra. Di, tri, or tetra. Di means 2. Sometimes you can use bi, it is acceptable. Di or bi, it means 2 groups. Dimethyl, diethyl, dipropyl, as the case may be. Tri, 3, same group. Tetra, that is 4, same group. So here I'm going to put di here. 1, 2, 1, 2. Dimethylhexane. Is that all? Let's continue with the rule. Rule number 4 says that some important groups are, so sometimes in our compounds, we can have these groups, especially when we are not talking about hydrocarbons alone, or some during the reaction of alkanes, it might come up with these special groups of elements or compounds or radicals. So fluorine, so we call it fluoro, chlorine we call it chloro when we want to use them in naming our hydrocarbon. Bromine, we call it bromo, iodine, like from the halogen groups. So, and then nitro, that's NO2, hydroxy, OH, amino, that is NH2, and so on and so forth. So those are special groups. Okay, let's check the last one there. Okay, rule number 5 says that when we have 2 or more different groups bonded to the main carbon chain, 2 or more different groups, they are ordered, that is, they are to be arranged alphabetically. So in this case, we don't have any particular case like that. So possibly in our next example. Now to complete this one, so we are to indicate the position according to rule number 3, position in which we have methyl group, second carbon, and fourth carbon. So we say 2, 4 hyphen 2, 4 hyphen dimethylhexane. 2, 4 the hyphen dimethylhexane. So this is the IUPAC name for this particular hydrocarbon. IUPAC name for this particular hydrocarbon. So let's say another one. Okay, branch alkanes just like this one. So we have from this diagram or structures, you can see the methyl group CH3, CH3. So we might try to name these compounds. We might try to name them. Okay. See the next slide. We have another simple one there, and they show to us how the structure is being named, just as we've explained up here. So this is hexane, as in the base name, just as this one, but it has only one branched group, methyl, which happens to fall on the third carbon. Ali, we start our numbering from this side 1, 2, 3, according to rule number 2. 1, 2, 3. So we assign the lower number possible to the branch group. We should start numbering from here 1, 2, 3, 4. So it will give us 4 methylhexane, which is not the appropriate one. Let me put it up so we can see it together. Just hexane like this is carbon. 1, 2, 3, 4, 5, 6. Okay, so we now have something like this, CH3 here. So the rest, hydrogen atoms, the rest, hydrogen atoms. Is that taken? Don't need to do that again because of time. Hydrogen atoms. So longest continuous carbon chain, 6. So hexane. So numbering. So this carbon has not been counted, it's not part of this name, hexane. And that is what? A methyl group, methyl. Then we should assign position to it, as in we should number it in such a way that the lowest number possible will be given to this branch group. That is what rule number 2 says. So if I start my numbering from here, for instance, 1, 2, 3, 4, 5, 6. So with this numbering, this my methyl group, that is my branch group, is on 4th carbon. So I will say 4-methylhexane. Okay, it is possible another student come up with another numbering system starting from this side. So we are still going to have methylhexane, but the numbering from here now will give us 1, 2, 3, 4, 5, 6. So can we all check it? So this methyl falls on the 3rd carbon. So for this one, we are going to call it 3-methylhexane. So according to rule number 2, we should start our numbering from the side which is nearer to the end, or we say we should give the lower number possible to the branch group. Based on that, this will be taken as the correct IUPAC name, why this is wrong. I hope that is taken. So that is how we arrive at 3-methylhexane. 3-methylhexane. Okay, next the style. Let me see if we have, yes. So we can now study these structures together. If you have any comment, you can communicate with me. Okay, can we see it clearly now? Look at these 4 structures. 2-methylpropane, 2-methylpropane, okay, yeah, I've rubbed it off. 2-methylpropane, one of the structures I have for isobutane. So for our isobutane, 2-methylpropane is one of its isomer. Then look at this particular one, isopentane, 1, 2, 3, 4. This is 5. So for this one, okay, we want to name this one. This is butane. 1, 2, 3, 4, butane. Isn't it? Butane. And then we now have a branch group. Okay. So if I should start my numbering here, 1, 2, 3, 4. So I'm going to have it as 3-methylbutane. Okay. On the other hand, if I start my numbering from here, 1, 2, 3, 4. So I'm going to have it as, that is 2-methylbutane. So according to rule number 2, this is wrong and this is correct. Is that taken? Okay. Now the one we have on the screen, we've gone through it. If there's any question, let me know. There's any question? Hello? Yewande, can you hear me?
Hello, sir.
Yeah, how are you?
Yes, I can hear you.
Yes, any question
I wanted to
for me?
ask the molecular formula for toluene.
For
Toluene.
toluene, molecular formula for, okay. I gave you that one as a part of aromatic, a derivative of benzene. Are you with me? Hello?
I can hear you.
Yes, benzene is C6H6, isn't it?
Yes, sir.
Yes, just remove 1 hydrogen. So that means we are now left with 5 hydrogen, C6H5. Then you now replace it with CH3. CH3.
Okay.
Yes, that is toluene. Toluene is the old name or trivial name for that compound. The IUPAC name is methylbenzene. And from the beginning of this lecture, if you are with me, So I gave that one specifically as a derivative for benzene. Methylbenzene is the IUPAC name. So toluene is the old name for it. Well, have you studied those
Okay.
four structures on the screen? Do you have any
Yes, sir.
problem with any one of them, as in the names?
No,
The names of any of one of them, any problem?
I don't have any problem.
Okay, thank you. Salaudin is Salaudin. Hello, Salaudin.
I don't have a question.
Yeah, how are you?
I'm fine.
Hello?
I don't have a question.
Yes, any question for me?
No.
Oh, okay, thank you. Mustafa. Mustafa, can you hear me? Mustafa? Okay. Any other person online? Oh, okay. Let's proceed. Almost done. Okay. Let's quickly look at this one. Yes. Look at this class activity. Yes, I'm waiting for the answer. You can type it. In order to save our time, you can type it. Type your answer for me. Name those two compounds. Those two compounds on the screen. I hope we can all see it. Yes.
Sir.
Oh. Mustafa. Yes.
The one you just cleaned off, I didn't really get it.
Oh, that one has gone some other time. You can check your YouTube later after the lesson. You can go to your YouTube and replay it. Yes. Any answer to that? Out of the two, anyone? Hello?
One, two, three.
Yes, anyone?
I'm coming.
Okay, you are still working on it. A or B?
I'll answer A.
Okay, I'm waiting.
A should be 2,4-dimethylpentane.
2,4-dimethylpentane. Okay, yeah, that's fantastic. That is correct. 2,4-dimethylpentane. Yeah, that is very good of you. Thank you. Anybody again?
You're welcome.
Fatia? Or Fatia, can you hear me?
No.
Fatia?
Yes, sir.
Yes.
The second one is that will be 3,5-trimethyl 3,5-trimethyl heptane.
Check it again. Just below the topic. Check it again. Okay. Now, let's quickly do that one together because of time. Let's do that one together because of time, then I will not give you assignment. Okay, so if we check it, this one is like a form of condensed formula somehow. It's not well spread out. like the one I used to draw on the board. So, but notwithstanding, we can still see the carbon atoms there. I can see this is one. Let us count together. 1, 2, 3, 4, 5, 6, 7. I can count 7 carbon atom being the longest chain. 7 carbon atom that gives us heptane. Heptane. Okay. Then the branches. We have a methyl group only. Methyl group. How many are they? 3 in numbers. 1, 2, 3. So that is trimethyl. Trimethyl heptane. What about position of those methyl groups? 1, 2, 3. So if I start from this side, 1, 2, 3. That's 3, 3, 5. 3, 3, 5. Trimethyl heptane. Okay, if I start from the other side, 1, 2, 3, 4, 5. 3, 5, 5. 3, 5, 5. Trimethyl heptane. Please check it again. Now, so which one will be the correct IUPAC name out of these two? 335 or 355 trimethyl heptane? Which one will be the correct one? Yes, Abdullah Salami. Can you hear me?
Sir.
So which one is the
Yes,
correct
sir.
one out of these two names? 335 trimethyl heptane or
335.
355 trimethyl heptane according to the rules? Can you hear me clearly?
335 trimethyl
Yeah,
heptane.
that is very wonderful of you. Yes, that is correct. 335 trimethyl heptane. Thanks very much. Then this is our next class activity because of time constraint. So you are going to have it as assignment. So write a condensed structure for, we have ABC there. 3-methylheptane, that's A. B, 2,2-dimethylhexane, and the third one, 3-4-dimethylheptane. Condensed structure. Right? First, just draw the structure if you don't know the condensed formula. So once you draw the structure first, then you can now just try as much as possible, follow the rules, and then cut it down just to minimize space. Yes, give me then the first slide. I think let me add more for them.
Sir, no.
Okay, lazy boy. Okay, hurry
Sir,
up.
no, it's okay.
Hurry up. Write a condensed structure for 3-methylheptane, that's in AB, 2,2-dimethylhexane, and so 3,4-dimethylheptane. Is that taken?
Yes, sir.
Okay.
So how are you going to submit this?
Yes, I will send my email address. I will send my
What?
address. I will send my email address.
Yes, sir.
My
Okay.
email address. Okay. Thank you all for listening. Have a wonderful day.